Assalamualaikum warahmatullahi wabarakatuh and hello everyone. This is a group presentation by a group 2 section 1 of the subject numerical method. Our group members consist of Nur Fatin Amira, Natasha Anak John, Nur Afika, Husna Raza and Rashid Awais.
So, in civil engineering, we actually rely heavily on data, especially in transportation and traffic field. So, for the road safety analysis, we actually need an accurate yearly accident statistic. For example, during the COVID-19 from 2020 until 2021, the statistic actually show the reduced accident due to travel restriction, but after the reopening, the accident rate actually increased again. So we are assumed that missing data actually can affect the planning of the future. So the solution of this problem are we can actually use the Newton divided difference method to estimate the missing data. Okay, so for the problem statement, we actually focus on the four content. First, the missing data described. For example, accident trend analysis, accurate feature prediction, and the policy decision. In this project, 2033 data is assumed as a missing data. So the goal is for the estimate 2033 values using the data from 2020, 2021, 2022, and 2024. This problem actually helps stimulate real-world data assurance in traffic engineering. Okay, so for the objective, this project aims to solve real-world data. So in this project, we are focused on three objectives. First, to estimate the number of road accident and death for 2023 using Newton divided difference method based on data from 2020, 2021, 2022, and 2024. Second, to demonstrate the use of numerical method in addressing missing data in civil engineering. Third, to ensure student analytical and computational skills in traffic safety and engineering application.
I'm Natasha Najon and I'm going to present on literature review. So the divided difference of Newton in numerical method is a field of mathematics that focuses on creating techniques for approximating solutions to problems that may be challenging or impossible to solve analytically. Interpolation is a key approach. So when only a specific collection of data points is given, interpolation is specifically utilized to estimate the value of a function for a given input. By iteratively computing split differences numerical values that indicate how a function or output varies in relation to changes in its input, Newtonian's divided difference approach creates an interpolating polynomial. These divided differences function as the interpolating polynomial coefficients and extend the idea of final differences. Newton's method is especially effective and versatile in contrast to some interpolation techniques, including Lagrange interpolation. Its ability to handle unequally spaced data point, that is, when the spacing between the input values nodes are not uniform, is one of its main features. This makes it more flexible in real-world situations where measurements are often taken at unpredictable times. Newton's approach makes it simple to update the interpolating polynomial whenever a new data point is added by building it progressively in a nested form, also known as Newton's forward form. For function fx, the generic form of the Newton interpolating polynomial based on data points is based on below. In fields like computer graphics, physics, engineering, and data analysis, where an estimate of a function based on actual data is required, this interpolation technique is frequently employed. Newton's split difference interpolation is a very effective technique for polynomial approximation in numerical methods, allowing for flexible handling of real-world data and quick calculation. That's all from me. Thank you.
For the methodology, first, we gather the fatality data from 2020 to 2024. After that, we will list the fatalities for each year and then create a table using years and fatality. After that, we will calculate divided difference by computing the differences for each level. Then, we will use the Newton interpolating polynomial to build the polynomial using the differences of each of the level before. Then, we substitute the year value to estimate fatalities, and lastly, we analyze the result by interpreting and compare the estimated fatalities of each year.
Okay, my name is Nur Afika binti Rosman. My metric number is DF230008. Okay, for the calculation, we need to estimate the number of road accidents in 2023 using Newton divided difference interpolation with the given data for years 2020, 2021, 2022 and 2024. Okay, the first step, we need to compute the divided difference for the first, second and third. The second step, we need to plug into the polynomial formula, and the last step, we need to evaluate at x equal to 2023. And this is the Malaysian road accident statistic from 2020 until 2024. Okay, for the first step, we need to do first order divided difference, which is we have three value of f. The first one is f at 0 as 1 equal to the value total accident of 2021 minus the value of total accident 2020 divide 2021 minus 2020. So we get negative 47,954. Same goes with f x1 x2 and f x2 x3. Okay, the second step is second order divided difference. We only have two value of f, which is the first one is f at 0 x1 x2 equal to the value we get from the first order divided difference for f x1 x2 minus the value for f x0 x1 divide 2022 minus 2020. So we get 111,628. Same goes with the value for fx1, x2, x3. Okay, for the third step, we need to do third order divided difference, which is we only have to find one value of f, which is the f at 0, x1, x2, x3 equal to the value we get from the second order divided difference from f x0, x1, x2 minus the value we get from f x1, x2, x3 divide 2024 minus 2020. So we get the value which is equal to negative 43,076.46. Okay, for the fourth step, we need to insert the Newton polynomial formula to find the value of Px. Okay, for the fifth step, we need to estimate for x equal to 2023 into the Newton polynomial formula, which is Px equal to P 2023, we get 685,687.24. After that, we need to insert the value we get into the divided difference table format. Okay, for the Fi0 is the value we get from the Malaysia Road Accident Statistic table from the 2020 until 2024. For the Fi1, the value we get from the first order divided difference. For the Fi2, we get from the second order divided difference, and the Fi3 is the value from the third order divided difference.
Hello everyone, in this slides, I will be discussing our estimation of the number of traffic accidents of the year 2023 using Newton's divided difference interpolation method. Using available data from the years 2020, 2021, 2022 and 2024, we estimated the number of traffic accidents in 2023 to be approximately 685,687 cases. This value was calculated using a third-order polynomial interpolation, which was suitable given our four data points. Interestingly, the estimated number of 2023 is significantly higher than the years before and after, suggesting a possible spike or anomaly. If this trend reflects reality, it will definitely warrant a further investigation. There are several possible reasons for this rise. It could be due to post-pandemic normalization, a sudden increase in traffic volume, or changes in road safety enforcement policies. This highlights how accident rates are not always linear. It can be influenced by external factors. This brings us to the value of numerical methods like Newton's divided difference. When real data is missing or delayed, interpolation helps maintain analytical continuity. For transportation engineers, this is crucial for planning, public safety, and making timely decisions. Of course, it is important to remember that interpolation does not replace actual data. Its accuracy depends heavily on the quality of surrounding data. Using higher order polynomial can cause overlifting or instability, so we must use this method carefully. In our case, a third order polynomial was appropriate, but it might not be in other scenarios. In conclusion, this studies shows how numerical techniques are practically applied in civil engineering, especially in traffic safety assessments. It trains us to think critically, work with incomplete dataset, and develop a real-world problem-solving skill. This has been a great example of how we can combine mathematical theory with a practical engineering needs. Let's continue using these tools wisely and critically for our future project. Thank you.
Conclusion. This project demonstrated the use of Newton's divided difference method to estimate the missing road accident data for 2023 based on our case study. It proved effective in maintaining data continuity, supporting analysis and planning in civil engineering. This method highlights how numerical tools can aid in real-world decision-making when an actual data is complete or delayed or is missing.
Thank you everyone for watching our video to the end. That's all from us. Thank you.